Okay, question 13. Here we've got parametric equations. We've got our domain for t between minus 2/3 pi and 2/3 pi. We're told that a, which has coordinates k, 1, and we're asked to find k. So obviously we know that the y coordinate there is 1, so we can substitute that into our y equation there. Okay, and then see if we can find t. So 1 on both sides, subtract 1, and we get minus 2 cos t equals 0, so therefore 2 equals, so therefore, well, therefore, okay, 2 cos t equals 0, and cos t therefore equals 0. So cos t equals 0, inverse cos of 0 gives us minus half pi, or half pi. So pi over 2 or minus pi over 2. I'm thinking about the curve there. Okay, put each of those back into the x function then to get x. So if t equals minus a half pi, x equals minus a half pi, minus 4, lots of sine, negative half pi, so negative pi over 2. And sine of minus pi over 2 being minus 1, so that's minus pi over 2 plus 4 in the end, so 4 minus pi over 2, which is incidentally positive. Okay, that's going to be relevant, I think. So let's just try with positive half pi, the other option for t. Substitute that into x. Then we get a half pi minus 4 times sine of a half pi. Oops. Now this time sine of half pi is 1, positive 1, so, then we get half pi minus 4. Now half pi minus 4 is actually negative. If you want to check that, just run it through your calculator. Now what we know from the diagram is that k itself is definitely positive. It's a positive x value there, and so therefore x is positive, and therefore k is positive, and therefore we're taking the overall positive one there, which is that one there for us. So therefore k must equal 4 minus pi over 2. Okay, part B, we're now trying to work out the gradient of the curve at point A. These are our Cartesian, so these are our parametric equations, sorry. Gradient is given by dy by dx. Okay, and we should know that then that's dy by dt over dx by dt. So differentiate y equals 1 minus 2 cos t, and we're going to get, so from our clock there, we're differentiating a minus cos, it goes to a positive sine, so we get a positive 2 sine t there. The 1 obviously differentiates to 0. Dx by dt, differentiate t, you get 1. Differentiate minus 4 sine t. Well, if differentiate minus sine, you get minus cos, so it stays minus. And there we go. So now at point A, if we look back up here, this was our k value, and that happened when t was minus a half. So at point A, t equals minus a half pi, sorry, minus half pi, minus a half pi, and t equals minus a half pi, and so we're going to just put that into there. So 2 sine negative pi over 2 over 1 minus 4 cos negative pi over 2. Okay, churn that through, so sine of minus pi over 2 is going to be minus 1, put that in the calculator if you need to. Cos of minus pi over 2 would be 0, so that's going to disappear to 0. So that's going to leave us with minus 2 as our gradient at point A. Okay, question 13 part C. Here we're told that the gradient is minus a half, and we're trying to find t when the gradient is minus half. So we know that that's minus half, but we also know that the gradient is 2 sine t over 1 minus 4 cos t. So we're going to set them equal to each other. Okay, and rearrange and solve. So I'm going to multiply through by minus 2 there to make that a minus 4 sine t on the top. That leaves a 1 over there. I'm going to multiply through by the denominator from there. Okay, then I'm going to add across that negative 4 cos t. So it's positive 4 cos t with a minus 4 sine t equals 1. Okay, now this is then of the form a cos x minus b cos x, so it's sine x squared equals 1. So that's the r cos t plus alpha form in this format. So we're going to have r cos t plus alpha. Okay, and because the minus there and it's cos, then the inside is going to be positive plus. Okay, r then given by square root of a squared plus b squared, so in this case square root of 4 squared plus 4 squared, and that comes out as 4 root 2. Alpha then always given as inverse tan of b over a. Well, that's 4 and that's 4, so inverse tan of 4 over 4. 4 over 4 is 1, so inverse tan of 1, that's pi over 4. Okay, sub those into this format here, and we get 4 root 2 cos of t plus pi over 4 equals 1. Okay, and then start to rearrange from there. So 1 over 4 root 2. T plus pi over 4, inverse cos there. Okay, and inverse cos then. Radians, so let's just get a calculator in radians. Go, radians, inverse cos. Right, 1 divided by 42. Oops. Right, inverse cos of 1 over 4 root 2. Right, 1.393, etc. Subtract across that pi over 4. And we get 0.60768, etc. Okay, and 0.6077 to 4 decimal places as required. And then just double check the domain. Well, that's okay. That's between the two values given in